Far beneath our planet's oceans, the predators you meet become increasingly terrifying. As we descend, the temperature drops, the pressure rises, and the growing dark expanse leaves little to hide behind. Creatures here have been forced to develop the strangest forms of camouflage found anywhere on Earth. Passing from the sunlit surface waters into the depths of the abyss, we encounter life's most bizarre adaptations. Transparent bodies, skin black enough to swallow all light, and flashes of color used to vanish into the dark. I'm Jordan Ferguson, and this is See It First. Join me as we discover the greatest disappearing act on our planet, the true masters of disguise at every depth in the ocean. Below the surface waves, we enter the Epipelagic, or sunlight zone. The brightest, busiest, most familiar part of the ocean, stretching from 0 to 200 meters down. Across the seabed, coral of every shape and color seems to spread out in all directions. Hold on a minute, that's not coral, it's a frogfish. Lumpy and uneven, this creature won't be winning any beauty contests, but it may be one of the most effective ambush predators in the shallow sea. From the top of its head, the frogfish carries a modified fin spine called an elysium, with a tiny fleshy lure at the end. Like a fishing rod built onto its body, it flicks this lure in front of its mouth. And to a passing fish, it may look like a worm, a shrimp, or some other tiny delicious morsel. As the prey drifts closer, the frogfish stays perfectly still. And then, in a sudden burst of speed, it opens its mouth and the victim vanishes inside. Then there's the ocean's most committed costume designer. The decorator crab doesn't just blend into its surroundings. It wears them. Using tiny hooked hairs across its body, it fastens pieces of algae, sponge, seaweed, and even living animals onto its shell. Piece by piece, it becomes a shuffling patch of reef, dressed to the nines in the greatest ghillie suit on Earth. The creatures of the Epipelagic zone use camouflage we understand. They blend in, impersonate, or disguise themselves. But as we descend beyond the sunlight zone, these tricks lose their effectiveness. And so camouflage becomes something far stranger. Past 200 meters, 656 feet down, we enter the Twilight zone. The sunlight hasn't disappeared completely, but it's fading fast. This is where you pass through the thermocline, a place in the ocean where the temperature falls sharply over a short distance. And by the time we reach the deeper twilight, the water is only a few degrees above freezing. But the real challenge of life in the deep is pressure. At sea level, our bodies live under 1 atmosphere of pressure. But underwater, every 10 meters down adds roughly 1 more atmosphere of pressure on top of the last. So at 200 meters, the pressure is already 21 times greater than at the surface. And by the bottom of the Twilight zone, 1,000 meters down, the pressure is 101 atmospheres, 1,500 pounds per square inch. That's like 5 Boeing 747s pushing down on you from every direction. But for the creatures of the Twilight Zone, this is home. And in this dim, cold, pressurized world, camouflage becomes stranger than ever. Drifting through the half-light with a transparent dome over its head is the barrel-eye fish. It's not a camouflage specialist, but rather one of the predators that makes it so necessary. 2 giant green spheres inside its head stare upward, watching for faint silhouettes passing above. Then there are salps, transparent barrel-shaped animals that move by pumping water through their bodies. Sometimes they join together in a long, delicate chain, blending into the dark water around them. But in the twilight, one creature stands out amongst the rest. The siphonophore. Imagine being the first to see such a thing. A long, fragile chain of living glass, almost invisible in the darkness. Incredibly, it's not a single creature. A siphonophore is a colony, made of many smaller living units called zoids, all connected and working as one body. Some help it swim, others reproduce, and still others hang below it as long, stinging tentacles, waiting for prey to drift too close. Sometimes these colonies grow to an impossible size. In 2020, off the coast of Western Australia, scientists sent a remotely operated vehicle into the deep canyons near Ningaloo. The cameras picked up something extraordinary. A siphonophore arranged in a huge spiral. The colony was estimated at around 45 meters long, and that's longer than a blue whale, possibly the longest animal ever recorded. In the Twilight Zone, transparency is a common survival strategy. The glass squid is a fantastically odd example. Its body is almost transparent, allowing the dim blue light to pass through it. But its eyes need pigment to absorb light, which means even when the rest of the body disappears, the eyes still cast a shadow. So some glass squid carry tiny light-producing organs beneath them, photophores. Using a camouflage technique known as counter-illumination, they glow just enough to soften the dark shape of the eyes when seen from below. As we descend further, cenophores appear. Rows of tiny beating hairs run along their bodies, bending the light into rippling bands of color. These hairs, called comb rows, act like tiny prisms. As they move, they scatter and refract the faint remaining light. For a moment, the deep ocean doesn't look so ominous. But as we drop below the Twilight Zone, this fragile beauty disappears. The last traces of sunlight are gone. Past 1,000 meters, 3,280 feet down, we enter the Midnight Zone. An open expanse of permanent darkness. In the distance, an eerie blue glow pulses in the dark. It belongs to an anglerfish. Hanging patiently in the water, its bright lure hanging in front of its face. A tiny lantern suspended in the endless darkness, urging hungry prey closer. out of that same darkness, a stoplight loose jaw appears. Its mouth hangs open, its teeth exposed, its body so black it's barely more than a faint shape cut from the darkness. Some can even produce red light, a color many deep-sea animals can't see, allowing them to search the darkness with their own personal torch, invisible to their prey. This works because light doesn't travel through water evenly. Near the surface, sunlight contains the full spectrum of colors. But as it passes down through the ocean, those colors are stripped away one by one. Red disappears first. Blue travels the furthest, which is why the ocean becomes a dim blue world before sunlight vanishes completely. But in the midnight zone, the only natural light is bioluminescence, most of which is blue because it's more effective. So many deep-sea creatures are tuned in to only see blue light, while red light remains effectively invisible. Few predators are more perfectly designed for the midnight zone than the dragonfish. Its body is narrow, its jaws are lined with long, needle-like teeth, and its skin is not just dark. It's built to swallow light. When researchers from Smithsonian and Duke studied deep-sea fish, they found that some species, like the dragonfish, had what's called ultra-black skin. It's so dark that it's able to capture more than 99.5% of the light that hits it. Tiny pigment structures called melanosomes are packed and shaped in a way that traps light inside the pigment layer. The perfect camouflage for a predator hunting in the dark. And even its teeth are part of the disguise. Dragonfish teeth are glass-like and transparent, which helps avoid reflecting even the faintest traces of light. So in the black water, the dragonfish can vanish completely, jaws and all, until the moment it strikes. But in the midnight zone, nothing is as it seems. A predator can become prey, and a creature that we might overlook can become the one that wins out. During NOAA's Discovering the Deep expedition in the remote Pacific, researchers were exploring the Ufyata seamount when they filmed something absurd. A deep-sea shrimp locked in battle with a dragonfish. And somehow, the shrimp was winning. The dragonfish had the teeth, the nightmare face, the body built for darkness, but the shrimp had it pinned and was feeding on it while the dragonfish was still alive. So the dragonfish might look like the final boss of the Midnight Zone, but life here can be unpredictable. Sometimes the monster in the dark gets taken apart by a shrimp. We're traveling now to a vast region of mud and silt, stretching further than the eye could ever see, if you could see at all down here. Welcome to the Abyss, a world unto its own, 4,000 meters down. Food arrives slowly from above, falling through the water as tiny fragments of dead plankton, waste, and remains. Scientists call these leftovers marine snow. In this quiet expanse, movement is costly, energy is precious, predators are fewer, and camouflage at this depth reflects the pace of life down here. In 2016, NOAA's deep-sea robot Deep Discoverer swept its lights across the seafloor and revealed a ghostly octopus that had never been recorded before. Almost immediately, it earned the perfect nickname, Casper. But Casper is not the only octopus haunting the abyss. Drifting through the darkness is another deep-sea relative, the Dumbo octopus. Another aptly named creature, it glides through the water flapping its ear-like fins on either side of its body. In the abyss, camouflage is no longer about dramatic disguise. It's about becoming less obvious, less defined and less colorful. Just another ghostly shape in the dark. And the abyss holds stranger creatures still. In 2017, scientists aboard Australia's research vessel Investigator were sampling the deep sea floor off the east coast of Australia when they brought up a fish that seemed to have no face. It was unlike anything they'd ever seen before. But when the scientists checked the records, they realized that it had in fact been seen before. It perfectly matched a species collected by HMS Challenger in the 1870s, during the first major scientific expedition to explore the deep ocean. The faceless cusk had reappeared from the abyss more than 150 years after it was first brought to science. But HMS Challenger didn't just uncover strange life from the deep. That same expedition also revealed one of the most surprising facts about our oceans. Just how deep they really are. Between 1872 and 1876, HMS Challenger sailed around the world on the first major scientific expedition devoted to exploring the deep ocean. Its crew measured temperature, collected animals, sampled the seafloor, and took hundreds of depth soundings at a time when the deep ocean was still a complete mystery. They lowered weighted lines over the side of the ship and waited for them to strike the bottom. Then, in 1875, while crossing the Western Pacific, the crew lowered the line once more. Down it went, past 1,000 meters, 3,000, 5,000, and still it kept going. The rope ran deeper into the dark than anywhere they had measured before, until finally, the weight reached the seafloor at 4,475 fathoms, 8,000 meters below. It was the deepest sounding ever recorded. They had found the Mariana Trench. And years later, the deepest known part of that region would carry the ship's name, the Challenger Deep, 11,000 meters, 36,000 feet below the waves. Which brings us to the final layer of our descent. Below the abyss, the seafloor drops away into long, narrow trenches, deep scars in the Earth's crust. Places where tectonic plates meet and one plate is forced beneath another, driving it down for millions of years. Welcome to the Hadal Zone, a layer of ocean beginning around 6,000 meters down and reaching 11,000 at its deepest points. Named after Hades, the underworld god of Greek myth, this is the deepest habitat on Earth. At these depths, the pressure is no longer just extreme. It's beyond imagination. The water presses in with 1,000 times the pressure at the surface. And yet, even here, life persists. One of the most remarkable survivors here is the snailfish. Small, pale, soft-bodied, snailfish have no gas-filled swim bladder to collapse under pressure. Their gelatinous bodies and flexible skeletons reduce structural stress, and pressure-stabilizing molecules help protect their proteins from deforming in the deep. In 2022, scientists filmed a snailfish 8,336 meters down, the deepest fish ever recorded on camera. But fish are not the final survivors of the trenches. Say hello to the sea cucumber. Relative of starfish and sea urchins, their bodies are soft, flexible, and committed to a much slower way of life. Many move across the mud as deposit feeders, taking in sediment and extracting whatever organic material the deep ocean has left behind. Others can lift themselves into the water column, flexing their bodies as they drift over the seabed. Their camouflage comes from the structure of the body itself. Color can be influenced by pigments in the body wall. Deeper colors usually mean more pigment, while paler forms contain less. But many deep-sea cucumbers go in the opposite direction. Their bodies can be translucent, and in some, you can even see their intestines. We've traveled from the sunlit surface of the sea all the way down into the trenches, looking at the strangest deep-sea camouflage at every depth. And with every layer down, the ocean has become darker, colder, more pressurized, and more dangerous. Near the surface, creatures survive by blending into their surroundings. In the twilight, transparent bodies and bioluminescence start to appear. In the midnight, predators erase reflections from their skin and even their teeth. And deeper still, in the abyss and the trenches, camouflage becomes quiet and ghost-like. And yet, this is only a glimpse of what's hidden at these depths. Because for every creature we've seen, countless others are drifting, crawling, hunting, and hiding in the dark. The deep ocean is full of life that has spent millions of years adapting to a world without sunlight, surviving in the weirdest of ways. And it makes me wonder, if camouflage is this strange in places we've only begun to discover, what else is still waiting down there, perfectly hidden in the darkness?